students, welcome back to the world of RoboMail. Let us start with the next module of the chapter, rotational motion, called as rolling motion. Now students, in this module, we're going to first define what is rolling motion, and then we're going to derive an expression for kinetic energy of a rolling object. So students, are you geared up? Fine. Let's move on to the module. Now students, what do you see on your screen? Oh yes, this is an inclined plane. So, let me consider a solid sphere. Now this solid sphere is kept at the top of the inclined plane. Now this solid sphere is right now at rest. I'm holding it now. The moment I release this solid sphere, what happens? The solid sphere moves down the inclined plane. Rather than saying the solid sphere moved down the inclined plane, I can say the solid sphere rolled down the inclined plane. So this solid sphere has performed a very special type of motion called as rolling motion. Hold on. What is rolling motion? Any guess? Oh yes. When a body rolls over a surface, then such a motion is called as rolling motion. Is that clear, students? Now, let us analyze this motion in detail. Now students, when I release this solid sphere moved down the inclined plane. So we can say this solid sphere performed a translational motion. Now if you watch very carefully, along with this translational motion, this solid sphere was also rotating about an axis passing through its center of mass, which is its geometric center. So along with this translational motion, this sphere was performing rotational motion also. So then, combination of translational motion and rotational motion will give you what, students? You can see over there. It will give you nothing but a rolling motion. So students, remember this. Rolling motion can be treated as a combination of two motions. What are those? It is the translational motion of the center of mass and rotational motion about an axis passing through center of mass. So rolling motion is translational motion plus rotational motion. Very simple, students. Is that clear? Fine. So let us move on to the second part. What did I say we are going to do in the second part? Any guess? Oh yes, there you go. We are going to derive an expression for kinetic energy of an object in rolling motion. For this, same inclined plane, same solid sphere. Let m be the mass of the solid sphere, r be the radius of the solid sphere. This solid sphere is where? At the top of the inclined plane at point A. Is it at rest? Yes, it is at rest. So initial velocity will be 0. The moment I release this solid sphere, what will happen? Very well. If I release this solid sphere will roll down the inclined plane. Now, let it roll to point B, and during the rolling motion, let it attain a linear velocity v. Is that clear? Now students, what is rolling motion? Yes, I heard you. Rolling motion is a combination of translational motion plus rotational motion. So then, what will be rolling kinetic energy? Any guesses? Very good students. Rolling kinetic energy will be kinetic energy of translation plus kinetic energy of rotation. Very simple. So let's carry this forward. I can write this as E is equal to Et plus Er, where Et is translational kinetic energy, Er is your rotational kinetic energy. Now students, I am very sure all of you know what is translational kinetic energy. What is translational kinetic energy? Yes, I heard you. Very good. Translational kinetic energy is half mv square. Now what is rotational kinetic energy? We have discussed. In the beginning modules we have discussed. What is rotational kinetic energy? Come on. Yes. Rotational kinetic energy is half I omega square. So now I have Et and Er. Can I substitute it in that expression of E? Yes. What will I get? E is equal to Et, which is half mv square, plus what is going to be your Er? Er is half I omega square. Now after this, students, is just simplification. And I'm very sure you can easily do this. How can you simplify? Come on, you have to guide me. E is equal to, first, half mv square plus, now hold on. We know the formula for I, moment of inertia. Do you know? Yes, you are asking me, sir, there are many formulas. Which formula of I? Moment of inertia and radius of gyration. Any formula? Yes, I heard you. Very good. I is equal to mk square. So if I substitute it over there, I will get half mk square omega square. Is that clear, students? So now, what will be the next step? Again, E is equal to, hold on, v, linear velocity. Any formula for linear velocity? Yes, you said something. What is that formula? V is equal to r omega, circular motion. Also we have used this in the previous modules. So V is r omega. What will be V square? Yes, V square will be r square omega square. So this will become half m r square omega square plus half m k square omega square. Now students, you see this expression is getting very interesting. Yes or no? Let's carry this forward. Now, see that term. Is anything common over there? Yes students, some terms are common. What are those? Half m is common. Omega square is also common. So I can pull out half m omega square is common. What will I get inside the bracket? What is it? Yes, you will get r square plus k square. Now students, I have boxed this. Why? Because this expression will be very, very handy in problem solving. But this is not our final expression. We can simplify this. How we can simplify this? This can be written as E is equal to the half m, hold on, omega. We know what is omega. Omega is? Yes, omega is V by R. So omega square will become V square upon R square into R square plus K square. Now after this students, it's just decorations. How can I decorate this equation? This can be written as E is equal to half mv square. I can take that R square inside. I'll get R square plus K square upon R square. Now students, I can solve this. You will get E is equal to half mv square. If you separate the variables, R square upon R square will become 1. So it will be 1 plus K square by R square. So students, this is the final expression for rolling kinetic energy. Very simple module students, very simple. Just you need to know, rolling motion is a combination of translational motion and rotational motion. Is that clear students? So I'll meet you in the next module. Until that, keep working, you can do it.